All right, ladies, this is lesson 4.7, and this is about in geometry. And this is about flowcharts. So in this class, we're not going to write formal proofs, but we should be able to give a reason for every conclusion that we make throughout, or like to give reason for why we think something is congruent or why we know that, you know, a certain angle is a certain measure. So we're not going to write a formal paragraph proof for these things, but we are going to use these flowcharts. So you may have used these in other classes to kind of organize your thoughts, but just to define a flowchart, and you'll recognize it a little bit when you see it, as you can see kind of on your note sheet too. But a flowchart is any kind of visual way to organize all the steps in a complicated procedure in the proper order. Okay, so again, we're just going to organize the thoughts that we have, just like we've been giving reason for every thing that we did before. We're just going to organize them that now in the order of which we know them. So we need to know the first thing before we can use that to show the second thing. So a flowchart proof is a way to present deductive reasoning. We're going to place each statement in a box and write how we know that statement below. All right, so if you look at your note sheet, we have this first example. And let's just talk through this first. And please think on your own too of how you know this, how you can draw your final conclusion, and then we're going to write it all into a flowchart. All right, so first of all, it tells you EC is congruent to AC. The first thing I would do, always if it gives you information, is mark that information on your diagram. So EC is congruent to AC, and it tells us that ER is congruent to AR. We want to know, is angle E congruent to angle A? So let's think about this for a second. All right, we have two pairs of congruent sides, but we don't know anything about any angles. But anytime we're working with triangles and we're trying to prove parts of triangles are congruent, we might want to try first proving the triangle is congruent. So in this triangle, see how they share this side, RC? We know that that is congruent to itself because it's the same segment. Okay, so we can conclude just by looking at the diagram, since that is the same segment, that RC is congruent to RC in both triangles. So now look at your triangles. Can we use any triangle congruent shortcuts? Well, we have a side, and a side congruent to a side, and a side in both triangles. So we can say that triangle RCA is congruent to triangle RCE because of side, side, side. Now, if we know those two triangles are congruent, then A has to be congruent to C, or to E. A is congruent to E because they're corresponding parts in congruent triangles. So angle A has to be congruent to angle E because of that abbreviation that we have, CPCTC, or that acronym. Corresponding parts of congruent triangles are congruent. All right, so now what we have to do is organize this into a flowchart group. So I'm just going to move this. Oh my gosh. All right, so just so we can see this, what we just did, this deductive reasoning part, so we can see it as we set up our flowchart group, because it's going to be helpful, because those are the steps we took to draw that final conclusion, and so now we just need to organize it in flowchart form. So the first thing we want to do is restate the given information. So for the logical, how we know this part, we'll just write given below the box. So it told us a couple pieces of information. The first was that EC is congruent to AC. All right, and then on this line, you're just going to write given, which on your note sheet, that should already be done. And then the second piece of given information was that ER is congruent to AR. And again, that piece of information was given. Now the third thing that we did, and it wasn't given, but it was very obvious by looking at it, that those two triangles shared that one side. So we could say that RC is congruent to RC because it's the same segment. So all of those pieces of information led us to conclude that triangle RCA is congruent to triangle RCE. And remember, when you write congruent triangles, match up the corresponding parts. So angle R, angle C, angle A, angle R, angle C, angle E. All right, so how did we come to that conclusion that those two triangles were congruent? We used the shortcut side, side, side. They had three pairs of congruent sides, therefore they are congruent. So that's a proven shortcut for congruent triangles. And then the last thing we know, after we showed that those two triangles are congruent, we know that angle A is congruent to angle E. And we know this because corresponding parts of congruent triangles are congruent. All right, let's look at the next one. So again, please pause, rewind as you need to for this video to make sure that you get all of the pieces of information down. All right, for this next one, it says angle ABC has BA congruent to BC, which is marked on your diagram, and it has CD and AD congruent, which again is marked on your diagram. The question is BD the angle bisector of ABC? So sometimes it helps to think backwards a little bit. So the final thing that we want to show, you can go ahead and skip forward if you want and write that in the last box. So we are trying to show that BD is the bisector of angle ABC. Now, we don't know this yet. That's what we're trying to get to. But if this is true, then what has to be true about those two angles? Looking at this, angle 1 and angle 2 are the two angles that make up angle ABC. So if BD is the bisector, what has to be true about those two? Well, we'll first have to show that angle 1 is congruent to angle 2. So we know that's going to be our second to last step. Now, we don't quite know how to get there yet. We can see that those two angles are in triangles. So we might try to prove that those triangles are congruent. So let's start with what they give us. Okay, so let's go back to the top of your flowchart. And let's just write down what we know from the given. So we know that BA is congruent to BC. All right, that was given. The second thing we know is that CD is congruent to AD. That was also given. Okay, so now there's a third piece of information that's going to lead us to our next conclusion. Again, anytime you're working with triangles and trying to prove corresponding parts of those triangles are congruent, like we are, angle 1 and angle 2, we're trying to show that those two triangles are congruent. So in order to do this, let's try showing that the triangles are congruent. So before we show the triangles are congruent, we need either side angle side, or side side side, or side angle angle. We need one of those shortcuts. Okay. So this one we already have two sides, and then we see that there's a shared side. So we can say that BD is congruent to BD because it's the same segment. Okay, so if we have all three of those pieces of information, then we can say ABD, triangle ABD is congruent to triangle CBD. And again, when you write congruent triangles, you want to match up your congruent pieces. And I always focus on angles because those are always going to correspond pretty easily. All right, so we know those two triangles are congruent because of side, side, side. So once we know those two triangles are congruent, then we can say that angle 1 is congruent to angle 2. Now, how do we know this? So angle 1 is congruent to angle 2 because of that corresponding parts of congruent triangles are congruent. So if angle 1 is congruent to angle 2, then BD has to be the bisector of angle ABC. And how do we know that? Well, this is just a simple definition. So sometimes it's as simple as just, well, that's what a bisector is. It cuts an angle into two congruent angles. So if ever you have a ray or a segment or a line that cuts an angle into two congruent angles, it's a bisector. That's the definition. All right, so please jot down any questions that you have. There are a couple flowchart proofs in your textbook that you should try for extra practice. And we can go over any questions you have in class. Thank you.